Hello everyone. Today, I will provide basic information about formwork scaffolding and work scaffolding modeling in the STA program. At first, our scaffolding screen appears like this. After it appears, to open a new project, we can see that we have the new project section on the left. We need to click here. When we click here, our project section will open after a short wait. Yes, our new project section has opened. The first thing we need to do here is to call our model. Here, you can see that we have the Staff Orchid Model Acquisition button. When we click this relevant button, we will select and acquire our model through the Model Selection and Acquisition section. I will call an example from our prepared data here. Here, you can also obtain the floors, axes, and, if you wish, the sloped axes while acquiring the model. Yes, our model has arrived. The process of acquiring the model is complete. After completing this process, I will first explain the formwork scaffolding here. How is formwork scaffolding modeled? What needs to be done? First of all, we have the building information section related to scaffolding. Here, initially, we need to adjust some features, such as section properties. Yes, we click here. When we click, a general screen like this appears in front of us. This is our general information screen. Here, you can enter and edit the project name, and company logo. This is a situation that is up to you. It can be arranged not only from here, but also in the same way. When we receive a report, from there I will convey that as well. Now, this was the general information section. Yes, there are some features related to scaffolding here. You can adjust the material property and the section property when the material property comes in. Here, you can select and adjust the elastic module based on the material you are using. These are the default values that come preset. You can enter the values in your project. You can adjust them. Adjustments can be made according to the type of material you are using. Then you proceed to the section part. The values in the section are, of course, obtained from the supplier company. They are sourced from the company that produces the relevant sections. Here is the column section for 1. It states which section we are using as a cross-section. Similarly, we have secondary sections below. As you can see, a rectangular section is used there right now. Of course, for this slab, for the first section of the slab, for the second section of the slab. Similarly, there are sections used for the primary and secondary sections of the key, and there are options for columns. You can specify these for secondary sections. You can choose either steel or wood. For example, how are these values changed here? For instance, the H20 section is used for the primary section. For example, if you want to enter a section in H20 format but with slightly different dimensions, you can adjust the sizes accordingly. It will take this into account and adjust the section accordingly. For example, let's say this will be 30, and you adjust it based on that. Look, it has changed right away here as well. You can adjust it yourself this way, or you can change the section. For example, you will use a rectangular section here. So it's up to you. Accordingly, you can change the writing format from here yourself. For example, let's say it is like this. Yes, look here. Victorian has changed secretly, for example, so you can either do these, or revert back to the old state. You can automatically select from the available hidden options here. Let's say this is a hidden example, for instance. You can also get such a hidden one. It's up to you. You can adjust the sections from here. Besides that, we have our telescopic post section here. Here, regarding the telescopic post, you can see that there are normal strength values and height values. If your height is over 3.2 meters, then it is modeled as a table-type post, according to the program attacks, not as a telescopic post. You cannot obtain drawings according to the table type post. You only receive the drawings if you have a telescopic post, but the calculation is made according to the table type post. If the height section is above 3.2 meters, if it is up to 3.2 meters, then it is considered a telescopic post based on the values you have entered. Here, if you have a height greater than 3.2 meters, then you need to enter the strength value for the table type post, because the calculation will be made accordingly. Additionally, as seen here, the strength values for the telescopic posts are also written here. Here is the strength value of the telescopic post used for the beam. Similarly, you can see the strength value of the telescopic post used for the slabs. Additionally, there are concrete properties here as well. These need to be obtained from the supplier company. These can be documented. The brace parameters are also found here. These also need to be obtained from the preferred company and documented, which is important. An important point here is to look at which index the braces should start from on the secondary beams. Actually, it indicates this here. So, what exactly does it mean to us? Now, braces are being created by connecting to the secondary beam sections. Here, the sections of the secondary beams are arranged from top to bottom along the structure. Row 1, row 2, and row 3 are lined up throughout the height of the structure. It indicates which row to start from. The second row refers to the beam section here at the beginning. The second section entries are being modeled. One row is being modeled and below it, the second row is being modeled, with braces connecting to the sections in this second row. In this way, you can determine which row it will be connected to. This aspect is important in this section. Now we have mentioned this part as well. You determine the exact specifications from here. In addition to this, if we come here, we have our structure tree section. The structure tree section is very important. It provides us with summarized information regarding all types of structures. From here, you can examine the structure tree section in terms of summary information. Similarly, when we conduct the analysis, you will be able to quickly view the report section and the drawing section here for your reference and preview. Besides that, of course, here you can see that if you click, you have the chance to view it as a floor axis. Here you can see the floor sections. This is related to the structure. You can obtain summary information. Yes, besides that, here you can see the section information and section properties. You can view all of these in detail from here. The structural tree section is important in that regard. Besides that, yes, our screen is currently displaying in 3D. When applying formwork scaffolding, there is no need for us to perform any analysis on the formwork scaffolding. We need to apply the analysis section for work scaffolding. In other words, we need to implement this part. However, there is no need for us to perform any such operation in formwork scaffolding. We are currently clicking the button to add direct forms to the model and adding them to the model. Yes, look, it has been added to the model now. After being added to the model in this way, you can of course make adjustments from here. When you open the report section directly, the results will also appear. Yes, this was the topic I mentioned a moment ago. Here we have a series of beams. Our second section beams and braces are currently connected here from the second section. In this regard, this is also important. Yes, if we click on the relevant column element here with the mouse, here we will encounter the adjustment of the formwork scaffolding. From here, we can also adjust the width and height of the brace. It has currently been determined automatically. We initially suggested starting with the secondary beam. Accordingly, the width and height were automatically determined. So we said to start with the beams that are in the second row of the secondary beam. Here, we can also take a different approach. We can change the order of these locations. We can solve this by directly providing the width and height values ourselves. Of course, we need to turn off the automatic sensing for this. You can also make that adjustment from here. Besides that, take a look at the relevant options. When we click on the slab element, we can also specify the post subcode. When we reach the formwork scaffolding settings, especially if there are intermediate floors and this has not been recognized, we can provide the post subcode. Accordingly, if you do not provide it, posts will automatically be accounted for along the height of the floor to go down to the next level. As we said, there is no need to analyze now. I am coming to the analysis section here. I am clicking on the report section here. Yes, we are choosing formwork scaffolding. There is currently no work scaffolding available. After selecting the formwork scaffolding, I click the report generation button. Yes, my report has been generated now. Here, the regulations used at the beginning are listed. Our material and cutting specifications are included. After that, the form calculations for the slab, column, and beam are provided in order, along with the formwork scaffolding calculations and their design results. You can examine these reports in detail from here. These are important. Here, look at the used posts, the capacities of the posts, the forces acting on the posts. And since our posts are shorter than 3.20 meters, they are already specified here as telescopic posts. Then there are calculations related to the column here. Yes, all the information related to dimensions, distances, forces is written here. Similarly, these calculations are available for beams and slabs as well. In this way, the report is already completed. There is an important situation regarding slabs. I would like to briefly mention it. As seen here, there is a coefficient for slabs. Now I will explain what this means when we talk about the number of floors. Here, the number of floors indicates how many scaffolds are needed below. So, for example, you we'll be building the second floor. While constructing the second floor, how many scaffolds need to be below? Here is what the scaffolds look like. On a floor specifically, on the first floor, it needs to stay there. You shouldn't remove it. But, for example, if you are on the third floor, then you will need a scaffold for one floor again. So you will have already removed it at once. Having two is sufficient. However, if two scaffolds are needed, then if there were two, you would need to support these scaffolds in terms of the relevant slab for both the first and second floors. This indicates to us directly how the number of floors is determined in this way. Therefore, when we arrive here, for example, there are some terms related to beams such as LBK and K. These types of values are explained in detail here, and we need to evaluate them accordingly. For instance, if we look at the slab, you can see the first support entries. Above, the distance between them is LBK, and the distance between the second support entries is L and A. L also represents the distance between the columns here. This way, their definitions are like this. Accordingly, the program automatically places these values. You can export the report here as a PDF file. In this way, you can save it in the desired format. And after saving, you can open it. Yes, look, it just saved immediately and opened it for me automatically. This way, you can also get a PDF output. Now, I want to quickly show the drawings. I will close the report section. In the drawing section, you can either obtain a direct formwork drawing or get the drawing of the selected formwork. Now, I have come to the form drawing menu. Do you want a slab? Here, column, or beam. Choose which one you want to know the formwork for. You can select either one, you can also choose both. What you need to do here is to make a selection based on the axis or based on the floor. You need to do this to obtain the drawing. For example, I am selecting the second floor after selecting look here. I am pressing the green tick. When I do this, the drawings are currently being processed and created below. Yes, look, the drawings have arrived. Here are the drawings for the columns, beams and slabs, and it shows our vertical supports. It writes the supports, writes the selected columns. Here, detailed dimensions calculations, or rather, columns, can be found in the drawings. After that, you can save these as a DVG file like this. You click here. You can save the DVG file to your desired location. You can obtain the drawing in this way. Of course, there is also our selected mold drawing here. You will need to select the relevant element here. This will allow you to obtain a drawing of the selected element. First, we select our element. Let's say we chose the slab element. Then, when we click on the drawing of this selected element, it provides us with the detailed dimensions of the related slab's form drawings here. The list of materials already in use is provided. A kind of measurement is derived from this. In this way, you can select the relevant elements and obtain the drawings of the selected mold. Yes, these are generally the things I have to say about form scaffolds. Now, you can quickly move on to modeling the CP scaffold. Yes, we have reopened the relevant model right now. Here, you need to make an addition for the work scaffold through this button. But before that, I will add a column. I will place my scaffold according to that column. You can add axes in this way. You can do it as parallel, circular, or as a general axis addition.
I will add a direct parallel axis. Here you can adjust the distance value yourself. From here I need to enter the negative side. I will create my scaffold for this side, and also for the side here.
Yes. I created it here. I created it right here as well. Now, after creating my axis, I will very quickly create it this way using this button. Yes, look, it has formed here. We can create it here in the same way. Yes, our scaffold has been formed now. Before moving on to the analysis section, I would like to show some features. Now, when we click on the relevant created facade scaffold, here, we encounter some features. First, we select our load type. From here, specifically, we can choose Section 3 for paint and liquid. In addition, we can consider the necessary floor numbers by entering values for facade cladding and wind. Here we have the dimension. From the dimension section, we can change the floor and height. So, we can reduce the height of our scaffold here. Maybe there will be a scaffold on a lower floor. For example, let's say 6. After saying that, we are saving it here. Look, it has lowered the scaffold, and its height accordingly. We can do this. We can change the existing codes in order to improve functionality and enhance performance. We can change the existing carpet. In addition, we have a look at our 3D lifting option here. Here, when we click, we can lift the selected facade scaffold. As shown here, yes, look, I am currently lifting it in this direction. Here, we are approximately doing this. After that, you can enter your actual value. Here, from here, you press OK. Yes, look, this way. You have lifted our facade scaffold. You can make arrangements like this. Besides that, if we look at the design and analysis section here, we have the option to select the bar finite element model. If you click on this, he is currently loading the bar finite element model here. He will show these. Yes, look, he has shown them now. When looking here, we can see that the rotations at the relevant point are 0. So, a support that is fixed in terms of rotations has been used here. We can visualize these. Besides that, look here, we have our load display button. When we click on this, it shows the added loads here in blue. Right now, here you can view the loads, including the joint loads. You can certainly select the loads from here. Currently, the dead load is selected. You can also select the live load from here. The live loads can be viewed here. Yes, when you close it from here. We did not perform the analysis. When we conduct the analysis, we will also display the bar forces and the analysis results here. As we mentioned here, we need to analyze it because it has a CPSK. Now I will perform my analysis. Here, look, we have the Start Analysis button here. I click on this and say, Run Analyze. Yes, our analysis is now complete here. We click the button to open the results. The results are coming in now. Yes, it has just arrived. Look here. We can visualize both the position and the displacements, translations, and rotations as points on the relevant element. And here,
When we click on the element, look, you can select the load here under the loads. Generated in layman. Currently, the dead load is selected. You can also select the live load. You can select different loads, such as wind load, snow load, and thermal load, and view the shear force and moment values generated under these loads, as well as the displacement values. Here, you can also check where the direct maximum values occur. You can see these. And here, look, it shows the forces acting on the position. When we click again, the same table from earlier appears, and you can take these values. Here, you can already see a scale of these values. Besides that, in the design results section, yes, look at this, the sufficient elements are glowing in green. Right now, all the scaffold elements appear to be sufficient. It is green because it is currently glowing. The color of all elements would have been red if there had been a deficiency. Or if it were an unplanned element, it would also appear in white. From this, we can directly obtain the design result. Yes, all deficiencies are taken into account here. For example, is there a deficiency under shear strength? Or what are the values? You can visualize this. As can be seen right now, they are all glowing in blue. There are no deficiencies visible. Here we already have our scale. When you hover over it, you can see that it indicates shear strength, deflection safety, and all of these are already specified in the dotted area. This way, we can also visualize them. Yes, let's close this now. Our analysis is complete. Here we also have our design summary section. Here, if there is a deficiency or error, it indicates that there is a deficiency in the field event element. It specifies this. Currently, it shows us that there are no deficiencies or errors. Yes, now let's move on to the drawing and report section. In the report, yes, when we click on this, we can obtain our report using the same logic as in the previous. Formwork scaffold. This time, since our work scaffold is also present, yes, I will select all of them now. This time I will not consider the formwork scaffold. Yes, I have closed it for now. In this way, we can still obtain our report. Using the same logic, we can create our report, and it is also indicated here that initially, there are no deficiencies based on the calculations made. Yes, the loads received, sections, and section information. Then, capacity checks are performed here. You can view them. The report acquisition is done in the same manner as in the previous example. When it comes to the drawing, I am now closing this comprehensive report. Yes, we need to click on the option here. You know how to select the scaffold option here and draw it. We were using the two options here, and we need to use this in the facade scaffold as well. When we click this, we can click directly here. Now it is creating the drawing, as you can see below. Yes, look, the relevant drawing has just appeared here. The relevant facade drawing has arrived here. In the drawings section, as we receive the drawings, you can see that our drawing is currently displayed under the General Drawings heading. As we receive a lot of drawings, these will be determined under the relevant headings here, and you can quickly view them from the structure tree section. You can also save it here as a DVG file. Yes, aside from that, if we come to the drawing part, we can obtain different drawings from here. I will show these now. Yes, we can also get a 3D drawing here. When we come to this button, if we select the 3D option and confirm, it will bring up the three-dimensional drawing. And we can also access it in the same way from here, from the structure tree section. As can be seen, there is a 3D structure drawing with information about the elements written here, the elements used in the scaffold,
are listed along with their dimensions. Additionally, we can select all of these elements here and view their drawings based on their general characteristics. This is how the used elements are displayed. We are viewing these from this option. Besides that, the general arrangement option, meaning here 3. Outside of the dimension, we can also take a drawing as a section from this alignment. For example, I want to obtain a drawing according to the axis here. He received a drawing according to this axis. The elements used here are present. In this way, we can also obtain its drawing. Finally, in our drawing section, we have the opportunity to take drawings according to the floors from the same position. For example, I can take a drawing for the 3rd floor. Yes, this is another asana that is already being formed. Yes, look here, I have also taken a drawing according to the 3rd floor, the scaffold elements used. It is visible here again. In this way, you have the opportunity to obtain different drawings. Yes, these are my comments regarding the scaffold. Thank you very much for listening to me. I wish everyone good work.